All right, good morning. Here we go. We're going to take a look at an ellipse now. Notice we have a parameterization. It just looks exactly like, well, it's similar to a circle, except for the amplitudes of our sine and cosine are different. So what you need to remember is that the cosine squared of t plus the sine squared of t is 1. That's the key idea here. That's what we're going to use. That's what we're going to drive into the ground. So the first thing I'm going to do is I'm going to solve this equation, x equals 13 cosine of t plus 2 for x, and I think I should first I subtract 2 and then I divide by 13 and I get the cosine of t. Similarly, I do the same thing for y, and I think that's going to be y minus 4 over 5 equals the sine of t. Using the substitution property of equality, we're going to have x minus 2 over 13, quantity squared, plus y minus 4 over 5, quantity squared, is 1. Now I know your book doesn't write their ellipses this way. When I look at my dilation factors, I see the horizontal dilation factor is larger. That means that's going to be the longer axis. The length of the major axis will be 26. The length of the minor axis will be 10. I'm going to go ahead and plot my center. It's not going to be accurate because I'm not on graph paper, but there's 2, 4. If I go 13 units to the right, that's a vertex. 13 units to the left, that's a vertex. Now, this is where I differ a little bit. There are some authors that just talk about the vertices, and there are other authors that talk about the vertices and co-vertices. I think of everything as a vertice here, because I have vertices for my major and my minor axes. Now I'm going to go up 5 and down 5. And of course, you know, I'm not doing this on graph paper, so it will not be, okay, it's not so, I shouldn't be an art major. Okay. The foci live on the major axes. So I see this right triangle all the time. The focal distance is the distance from the vertex to a foci. I'm just going to call that F1. If I reflect this point over the minor axes, I'm going to get the other foci because they're symmetric to the vertex. And they're both on the major axes. My minor radius will go here, and my major radius goes there. So I have that c squared plus 25, which is 5 squared, is equal to 169, 13 squared. C squared is 144. I'm going to take the square root. This is a focal distance. The absolute value of c is 12. And honestly, I could think of this as a variable and say it's plus and minus, because I'm going to go 12 units to the right, and I'm going to go 12 units to the left. So my foci, I'm living on the x is 2. I go plus and minus. I do believe that's 12, but I leave the y value alone. So that means one foci is at 14.4, and the other foci, I think 2 minus 12 is still negative 10, right? And don't forget the 4, like Mr. Isaac. So there are my 2 foci. There are my focal points. Now, let's see, what else do I want? I want the domain. I want the range. So my domain, let's think about this. We're going to take the center, which is 2, and I'm going to go 2 minus 13. I hope that's still minus 11. I'm going to go 2 plus 13. Oops, I hope that's still 15. There's my domain. My range. Okay, I take my y value of my vertex. That's 4. I'm going to go 4 minus 5. I think that's still negative 1. And I'm going to go 4 plus 5. I hope that's still 9. I hope this helps. These are all on YouTube.